Okay, so I'm going to do a series of little snippets, little videos about our basic coding standards, what your code should look like, and some of the reasons for why we do the things we need to do. So this is starting out with our basic coding standards. I'm going to be using the UML class diagram for rectangle that I've provided. This is quite often the first class one writes in a lot of introductory programming classes, and it's something we're all familiar with, so I think it's kind of an easy thing to work with. So to look at the UML, kind of talk about it to begin with, as I mentioned in the UML basics video, we have attributes and we have operations. In this case, we have two attributes, a length and a width. Both are double type values. Off to the right, we have a short description of what the attributes are. It's pretty obvious, but I don't see any harm in adding obvious comments. Operations, we have two constructors to begin with. Okay, public rectangle, open parenthesis, followed by the parameter list if it exists, close parenthesis, colon, rectangle. We have a null constructor and a full constructor. In both cases, when the constructor ends, when that method completes, it will return back to the caller, whoever / whatever called that constructor, will receive back a reference to a newly created rectangle object. In this particular instance, I've gone ahead and included the set and get methods in our UML. Just to reiterate what I said in the other snippet, that's not standard. In standard UML, standard usage in large organizations, set and get methods are simply understood to exist. We don't explicitly state them. I provided that here because I want to make sure we've got something to go back to. You've got a reference you can look at as we walk through building this code. We've got two other methods that we're going to include. Calc area, because I didn't want to write out the word calculate. Calculate would be the verb. This is a method that is going to calculate the area for the rectangle object. We also have a calc perimeter method. This method will calculate the perimeter for the rectangle object. We all took geometry. We know how these formulas are supposed to work. I've listed them out anyway. If you are using a formula, it's always good habit in your UML to state it explicitly. Then we have our toString method. We should always include a toString, whether it's in the UML or not. Tostrings are beautiful, very, very useful things. I always include them in my UML. So that's a rundown on the UML we'll be using. I'm going to try to switch over to Dr. Java from here. Please be patient if it takes me a moment. I'm still new to this. Okay, so this is Dr. Java. We have up. One thing I would ask you to note, okay, a couple of things. I have the line numbering turned on. Please always have your line numbering on. It does make it a lot easier when you're trying to find problems in the code. If you have compiler errors or if you have runtime exceptions, those are invaluable. I would also point out the compiler, JDK 8, the rest of it's not really relevant. We're not going to worry about it, but it must be JDK 8, not 7. 9 will not work. Anything 9 or above will not work with Dr. Java. Also, please don't use the Eclipse compiler. You're welcome to use it, actually. The problem comes in when I compile and execute your code for grading. The Eclipse compiler handles things a little bit differently sometimes. It can create some issues. Okay, so let's dive into the first part of our rectangle class, the very first thing I want to talk about before we start typing code at all, I want to point out that from this point forward, you're going to have two groupings of source code. You will have code that describes things, describes objects, describes a rectangle, describes a policy, describes a class, course. Let me use that so we're not confused. Describes a course in your curriculum, describes a book, describes any sort of noun. Okay, that is your descriptor class. That's what we're going to be working on now. You'll also have code that uses those objects, that issues a policy or updates a policy, that creates a student object, that at the end of the semester updates student object to add credit hours to updated GPA. Okay. The action, the process, the task will be separate from the description of the object. Code that describes objects, the name will always be a noun, a singular noun. Code that works with objects, there will be a verb in the name. That's standard. It makes it easy for us to keep the code separate and to understand it. The reason we do this, I probably, if I am the university, need to access the object, the student type object that represents you from literally scores of processes, literally dozens and dozens. I can't afford to describe you every single time. So we do the description once. We keep that code, both the executable and the source, and we access that code from all of the processes where we need it. So that's why we're keeping this separate. You're never going to see those two things living together ever again. Now, I always, and according to the basic standards, so shall you, start my code with a block comment. It does not have to be a long comment. It can be fairly short, but you always want to have a comment that describes what we're doing in this particular source. This class, forgive my typing, it's really sad. This class describes a rectangle object. Its attributes are length, and width. It will define several methods that can be executed by or on a rectangle object. Doesn't have to be lengthy, doesn't have to be in a lot of detail, but it's a really good idea to include that little bit to explain what you're doing, just so that it's easier to find the code you need when you want to reuse code. Honestly, that's one of the big reasons to do it. I like my white space. There will be a lot of that here. White space has no cost, and it makes reading your code easier. So we have a class header, public class rectangle. You'll notice that I did my opening and closing braces instantly after my class header and then added a line comment after the close. This is a habit. It, for me, is a very good habit. It helps me avoid having problems with my scope. It helps me avoid forgetting or misplacing a closing brace. Having the comment at the closing brace makes it clear what the scope is that is supposed to be ending there. it actually does help with debugging. I also really like my braces on their own lines. I put nothing else except line comments on lines with braces. That's not a requirement by the coding standards I've published, but it is a recommendation. Once I've said this is going to be my whole scope, I come in to begin actually adding code. What we're going to do in this little video, because I want to keep it short, we are going to do only instance variables and constructors. Okay, only the instance variables, because I need to talk about those a little, and the constructors, because I need to talk about those a bit too. So our instance variables, if you go back to the UML, you will see they're designed to be private. I really can't spell today. They are both doubles. The first we have is length, private, double, width. Okay, a couple of notes here. Do not alter the names of your instance variables. Stay with the UML. You may not like the name. It may not make perfect sense to you. You may think there's a better one. That's fine. Don't change it. Stay with the UML. The UML you should think of that as holy writ in stone. It cannot be changed. Our instance variables will always be private. Always, 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 always. This provides a little bit of a barrier around our instance values to provide outsiders from accessing them in any way, to help protect them from outside influence or outside being exposed to an outsider. It's not a perfect solution for security, obviously. It is not a complete solution, obviously. But we have these small steps we can take in Java that will help us make our code more secure. You can think of it a little bit like locking your door when you leave in the morning. Locking a door is not a guarantee that you can keep an intruder out. But if you've got a good lock on the door that you consistently use, you know for a fact that you can at least slow down an intruder, right? Same idea here. This is sort of a lock on the door. Always private. Again, your instance variables should always be named exactly as they are in the UML. You should always define them in the exact same order they exist in the UML. Your designer almost definitely had a reason for why they did this. Just take your designer's word for it. So that ends our instance variables for this particular class. Actually, I do want to add I like comments. You cannot over-comment code. I honestly have never seen that done. Please be really generous with your comments. The next thing we want to do is define our constructors. Now, typically with our constructors, we're going to start with the null constructor. That's not an absolute, and there will be instances where, in fact, you don't even have a null constructor. But where you do have a null constructor, it is typically going to be the first one you want to include. Constructors are always public. We can't build an object if our constructors are not public, so they are always public. They always carry the same name as the class in which they exist, rectangle for us, because they also carry a return type of capital R rectangle in this instance. We're not going to use both of those. This is where the method header for a constructor is a little different from standard. Standard would actually read public capital R rectangle, followed by the parameter list. Redundant and a little confusing. So the designers for Java said, yeah, we'll just use that class name once. Okay. Then we've got our parameter list. In the case of a null constructor, there isn't one. So that is an empty set of parentheses. Again, I like to make it clear what scope I'm ending. One of the reasons for that If you ever get messed up, you're unsure about your scope, you can click right after or right before one of these braces, and your IDE universally will help clear up. Oh, that's the scope for the whole class. Okay, that's really what I intended. Okay, that's the scope just for the null constructor. Okay, I know where I am now. And I like to put a little comment in here. It doesn't have to be long, but where I have an empty scope like that, I always like to throw in just one quick little comment. No, really, I meant this to have no code. By doing that, you make sure that anyone else reading your code knows that you knew what you were doing, and they don't have to come back and ask those questions. I try to make life simple for myself with my code. It's a good goal. We have a second constructor. This is the full constructor. In this case, we need our full defined parameter list. The first will be a double. I'm going to just abbreviate that word length here, and I'm going to do the same thing with width. Now, a couple of notes about our parameter list. You could use the word length and you could use the word width just as they are in the instance variables. You can make it work that way. I don't really recommend it. We want to distinguish or separate, make clear that these values coming into our constructor are not yet the instance values. At this point in time, right where my cursor is this moment, right there, those two double values do not my object make. They have not been set into the object yet. It just makes it more clear to me by using a different name. The other part of that is, in this course, you will not use the keyword this, T-H-I-S. That Java keyword, strike it from your vocabulary now. It is perfectly fine and perfectly functional if you understand what it does completely. But for someone programming at the level that I expect to see you at, which is not quite expert yet, debugging with the use of that keyword is horrendous. Let's not walk into that tar pit. Let's just not do that. It's so easy to avoid. Stay away from that keyword. Now inside this constructor, this full constructor, we're really going to have just two lines of code, but they probably don't look like what you were expecting. What we're going to do is correctly punctuate, and we are going to call two methods. These are our set methods, which we will write in another video. These are our set methods. We do not directly access instance variables in our Java, not even within the class, except through the set method or the get method for that variable. Direct access is absolutely, irrevocably forbidden, except in set and get methods. We put the private on our instance variables to provide sort of a barricade to keep everyone at arm's length. This is enforcing the barricade. This is making it higher or deeper so that it's a little harder yet for an outside actor to touch our variable values. We want to make that as difficult as possible. We don't want to make it impossible. We want to provide a path whereby these things can be done. Our set methods provide the path, but we want to make sure that that path is the only way to do it. So calling the set methods from the constructor helps us to reinforce that. And that's where I want to stop here. So I would recommend saving this code because you're going to pick it up in a moment. I'll save it when I close because I've got a special place to put all of this. But I recommend that you save this. We're going to pick up from this point with the next video. Thank you.